Okay, so this video, I'm sorry, is going to be me just rambling on for quite a long time. So, first of all, what am I trying to do here? First of all, I'm trying to get an idea, just out of curiosity, because I've always go fishing here and I've never had a careful look at the rocks. So I'm kind of curious about that. I'm also curious about whether you can just look at the rocks and know what the geology is. And so I've got the geology there. I'm also kind of curious about what that one looks like because I'm hoping to go for something that's a little bit wild. Probably the best you could ever see. There's two plates here that have collided, but this plate doesn't end in the ocean. It's up on the earth here, and so there's massive metamorphosis. So it's right here, so it's accessible. And the rivers and the typhoons and the earthquakes all break all the mountains and rocks up, and you can just pick up jade and all sorts of crazy metamorphic rocks just on the rivers, and they're just everywhere. No one cares. So I can't wait for that. I don't know anywhere else on Earth that is like that. Most everything else is the plates are going underneath. You don't get to have access to deep inside the Earth. So anyway, so I'm sort of curious about getting some background knowledge about that. So just looking at the rivers in a bit more detail. So there's quite a few reasons why I'm doing it, and this one here, I think it's just by absolute random chance because I used to go fishing here and here and here, every week, for the whole day. We used to go up and down the rivers and everything. So I know all this area really well. And it just so happened, I think probably the reason why we did this because it was so amazing. And I think the reason it's so amazing is because there's a fault there. And so because there's a split, all those metamorphic rocks come out. And so all the other rocks will weather and erode quite quickly, so the sedimentary rocks won't be there. It's the nice metamorphic rocks that remain that made that place really, really nice. So that's probably why we went there. And so I'm looking for these greenstones as well. And so I'm going to start here, which is not going to catch the greenstones, and then I'll find that I can actually find some greenstones, I think, further down where they wouldn't have really spread over here, but they would have spread down in this direction because they're just in this line here. And you can see because of the fault, there's been splits and pressures. So there's sort of metamorphism sort of happening here, regional metamorphism. And you can see there's this, they say diorite. So that's sort of like the granite, the light coloured, the rhyolite, but I couldn't see any of that. It's all basalt. Anyway, talk about that later. And what's here? This is sort of sedimentary rock, and so this has been impacted by the pressure here between the two. Okay, so hope that makes sense. Why there's a couple of reasons why I've chosen this particular spot. Why North Pine River is the place for me to go. And so if I look up, this one's a recent study. And what year is that? It's like 2003. Maybe not recent. Recent enough because they're just looking at the surface geology basically. And so they're saying that there's like 20% greenstones and 30%. What do we got? Sort of igneous and sedimentary rock that's got undergone some metamorphism, and same with the fern valveds, so maybe like 60, 70, what's that, 76 or 70%, and then a little bit of tiny bit of igneous. So I think that's basically true here. You can see this. I just took a picture there. I took a few, but they all look the same. There's just basically heaps of browns and blues. So I'll go into the next slide soon. The blues are sort of the basalt that may have undergone some sort of metamorphic changes, and the browns look like some sort of mudstone or shale, or even not really sandstone, that also seem to have gone some slight metamorphic change. And so here's the blue coloured rocks. It looks better under the sun. It looks quite blue. And this is under a lamp, and that looks much darker. And it is just the matrix, so the fine matrix. As you can see, there's possibly a quartz vein sort of starting to form. So it is sort of a metavolcanic, metabasic or metabasalt. There's all these silly words that geologists have that mean the same thing. All right. It's in one of the other slides. And the browns, metasediments or sedimentary rock with a little bit of metamorphism going on. There's some sort of crystals, I guess, being reformed. And it's quite baked. And it's very, very hard, extremely hard. It's definitely not. A sedimentary rock just crumbles and breaks really easy, and this is very, very strong. Okay, and then the quartzite's are less common. This one's my favorite. I love this red. It's all over the place actually. It's less common, but it's if you look at a particular picture, you will see them. You'll see a couple of them. I probably need to zoom in. And that one they all look like a sugary quartz appearance. So that's the classic quartz appearance, and that one's obviously got lots of iron or something in it to make it nice and red. Could be manganese or something else. All right, someone give me 50,000 for an XFS or something machine, so I can just zap it and tell you exactly what the elements are. So this one, there's a lot of phyllites. I don't know whether this one's phyllite because it's soft. I expect the shale, it goes from shale to phyllite to something else. Where's that? If I just jump to this, slate to phyllite to schist. As soon as it gets to slate, it's very, very hard. But this does have foliation surfaces and they're shiny. So maybe it's a phyllite that's undergone weathering. Because it's definitely got the nice foliation, and it's in the sun. These are like so shiny, like they're really, really shiny. You can see all the little crystals there, but under the lamp, it's not so much. But this one crumbles. It's the only one I have to keep in a bag because I don't want dust, sand going everywhere. So maybe it's just weathered out. Okay, so there wasn't much of that. I think maybe because of the weathering. I don't know. All right, and so. You can see I've got a general agreement. I don't have any greenstones, but that makes sense because I'm not in the right spot. I'm over here. That's where I took the survey, and we worked our way down. And so I find what I think is a greenstone and a lot of stones that are green down here and even around here. And so the surveys sort of make sense. But you need to consider all the other issues. Now, it just so happens that I've known about this place for my whole life, since I was a little kid in primary school. So I know that that is a shock to me. That is just absolutely horrible. So what that used to be, we used to go up here every weekend. And in my last video, you saw I used a trap. And that particular section as well is further up than here. So that was the place I went to the most. This place we went to, fairly common, but the most we went to was where I threw that fish trap. But this place was exactly the same. And the method that we used to use, because we used to survey all the fish that were in the river. All right, why is a little kid surveying all the fish in the river? Because his dad's got a PhD in marine biology and has a book full of fish, and basically, I'm just tagging along with a scientist, okay? And so he would, I'm sort of his sidekick, put the net in there and would have these huge boulders to secure it. And as I'm sort of pushing all the fish down, taking in turns, you've got to move the boulders to get because all the fish hide under the gudgeons, the shrimp, the lobsters. It's amazing what used to be in there. And so some of these are so big you just can't move them. And so, and you've got to watch out where you are too, so you don't get washed out by the water. And so, you're doing that for hours and hours on end, week after week, year after year. I've got a very good idea what the river looks like, and it's not this. All right, there's no rapids, there's no water, there's no channels, there's nothing. They've just trashed it, and it's all muddy and dirty and crap. Okay, and it's forever gone too, by the way, guys. It's lost it. You'll never see it again. All right, and so that's my eyewitness account. You just have to. There's no way that it was looking like this, because you can't do what we did when it's like this. It has to be like this for you to do that method. There has to be channels and rapids and large rocks and all sorts of stuff to do that method, to flush fish and everything else in the river into a net, to know everything that's in there. And so that's pretty tragic. I saw, and I actually saw this exact spot. I saw all the earth moving equipment, those big cranes that scoop up and then they dump it into trucks. I saw them do that recently in the last 10 years. Even though the documentation of them, and this was nice back when I was a kid, so it was recently in the last 30 years or something that they destroyed it. But even before I was born, it must have been even better, because they were destroying it back in the 60s. That's before I was a good 10, 20 years before I was even born. And so they took they just completely demolished the rivers even before I was born. So even the amazing rivers I saw back then, they must have destroyed a good portion of other rivers before then. But even up until the 2020s or 2020, even up to 2020, they're still destroying the rivers. Why? For no reason at all. To make a road. Oh my God. Forever. All right? Destroying this amazing, beautiful river forever just for roads. Oh, it's really, really. I never the reason I'm going to these old journals is because we destroy so much of the environment and build over it with houses and stuff that it's kind of ironic that the old stuff is the important stuff and tells us what it was really like and what's happening, because we lose it and we've lost it now. So the only record we have is maybe oral history of what I'm giving you and old records. And so, this guy says it was basalt. Okay, that's what it was. It's all gone now. Okay, so it's pretty much 100% basalt. Although the new, what is that? That's basalt, finely ground blastoporific rock, the granoblastic matrix. So they're just basalts that have gone under slight dark fine-grained rock. Hornfels, that's basalt. So they're all basalts with a slight metamorphosis. You're not going to see any of that now. All right. So what are you going to see now? This is a recent one, but even that's not reliable depending on where you are. Okay, so where was I? So another big question for me is, because I've been watching the basalts in America and the explanation about all the geology there, is that how do you even get liquid rock to start with? Because there's no liquid rock. It's thousands of kilometers underneath apparently, and so the theory is it's all it's under high heat and pressure. So if you relieve some of the pressure by having a fault or a plate movement, that will allow the rock to turn into liquid. Much like if you get water and put it in at room temperature and put it in a vacuum. So if you put it in a vacuum, decrease the pressure, it'll change state. It'll start boiling, and the water will turn into gas. And so that's one probably the most logical way. The splits and pushes and stuff changing the pressure, that will cause it to automatically just turn into a liquid again, or for the first time or whatever. Again, because it must have been hardened from the surface. And then the hot spots are another sort of theory that there's a really hot area in the mantle, and that's just making it weak and melting in a particular spot. The other big issue is there's basalt all over the place. and so it should be. It shouldn't be basalt, and the basalt is the magnesium and iron-rich magma. That's a dark color. That's in the ocean crust and way under the continental crust, which is a light color, the granites. It's full of the pink feldspars and the white quartzes. And so you should get the rhyolite, which is basically a red or a light colored basalt. So that's what you should be getting. But because we've seen so much, if I just jump to the maps, so what seems to have happened is this volcano here, Mount Warning. Look how massive this is, hundreds and hundreds of kilometres. This is New South Wales. It's another state, and that's Brisbane over there. So that rhyolite has, like over here, there's, meters and meters. How many meters? 10, 30 meters of condensed ash that far away. And then there's pumice everywhere. So it's tough and rhyolite everywhere. So what happens is this has been so, look at the distance, look at the magnitude of these things. It's that big. Oh my God, it's that big. All right, like nothing you've ever seen. Nothing that's ever been. What's been recorded that's like that? St. Helens. This is just unbelievable scales. Anyway, so it's what Professor Wisely, I think, has been saying, because there's the same stuff going here. There's like basalt floats in the middle of the continent. Is that there's been the volcanic activity has been so enormous that all of the continental crust has melted and exploded and been thrown into the air, and you've got tuff, which is the welded tuff, which is the ash flows, and you've got pumice and all of the light rhyolitic, the feldspar and quartz-rich magmas, the lighter stuff is gone. And the only thing now that we're just left with the stuff that's way underneath, which is the mafic, the magnesium and iron, the dark, are now coming up. And as you'll see from the road cuts, that is all everywhere, all along the roads and everywhere else. And all the glass, like there's basalt just all over the place, everywhere. All right? So we're talking about volcanic activity like they can't explain, basically. All right? And it sort of makes me wonder, how accurate their stuff is. All right, but anyway, maybe I should get into that. So this is theory. So the issue is this is theory. You look at the depths here. So you need to realize they don't understand any of this, and this is just theory. There's no repetition, there's no testing, there's no scientific evidence. The deepest they've gone past 12 kilometers once, and that was 30 years ago. And then they've gone past 10, so the Chinese did it last year or the year before. And then they got there and then realized everything's wrong, right? So there wasn't basalt at 7 kilometers, like the seismic waves. So they can't even tell what's going on 7 kilometers underneath. It was granite the whole entire way, and nothing they thought made sense. The temperatures were wrong, the seismic waves were wrong, everything's wrong. So they only ever went down once, only to discover that everything they know is wrong. So you've got to wonder. So if they've never gone down once, what concerns me is that their radioactive dating, what's that based on? They have no idea on what the initial levels are and if the levels are different throughout the center of the Earth. So all of their radioactive dating is based on wild assumptions, which is not science, and that it's not repeated, and it's not repeated in the laboratory. It's not science. So when they said it's millions and millions of years and billions of years, I'm willing to accept that and take that in, but it's definitely not scientific, and it probably shouldn't be taken. They need to review that. And one of the big reasons they should review that is it doesn't look slow. It looks quick. Look at these stretch marks. if this happened over billions of years, erosion would have taken it all out. You wouldn't see it. And the magnetic changes, if they didn't happen quickly, all of the animals that use magnetism for migration would have died. And how would they have ever established? I don't know. How would they have established that if it just changes? If it changed over one lifetime, like it says, like we have an oral history. Sorry to go into this. Delete this if this really puts you off, because I know it does. But in Genesis, we have an oral history that this all happened during one person's lifetime. The entire world split up. And for me, it makes sense. It looks like it's a quick thing. The second thing is, who would have written thousands and thousands of years ago that the world is split up? That whole idea that Peleg was this was one continent that split up, is a theory that's only been around for 100 years or so. Why would you even say that unless you saw this, unless it was true and you saw it, the earth splitting apart? So you have to deal with that as a witness. I think just as the same way you have to deal with the fact that I actually saw boulders in these rivers and was fishing and it looked like this and now it doesn't. You have to deal with my testimony. Why would I make that up? And how could I be so wrong? And so why would someone make that up, and how could they be so wrong? And you can see that the evidence supports what I say. You can also see the evidence in the earth of massive geologic activity that seems to be quick and a one-off event. So, there's millions and millions of years that is mandatory to be accepted by geologists. You've got to be open to question stuff. Their stuff is not scientific. Taking someone's eyewitness account is the definition of science, although it's not repeatable. So, all right, I did say I was going to ramble a lot, so there you go. I'm rambling. Okay, so back to Earth science has so many issues, it's not funny, but let's just move on. So we're in this area here. So we're sort of getting the green, it's either Greenschist or Green Hornfels. Now I'm trying to work out what Greenstone is. Now GeoGirl, I know she calls herself GeoGirl, but she is a professor at, I think, Idaho University. These are geology professors, these people. And she basically says it's greenschist with these green type minerals. But if it's not foliated, then they call it the greenstone. And Hornfels would be here, and it's all sort of around this area. Okay. And you remember, they have never gone past 200 or 10 or 12. So when you look at these pictures, you got to realize that little square they've looked at once. Okay. They've never gone past 200. They've gone past 10 once. So it's in the realm of that hasn't been verified or checked. They haven't been able to get to it. So it is in some ways theoretical. And for the sedimentary metamorphism, which are called metapellites, metasediments, I'll just call them whatever, you'll see the chlorite, muscovite, the shininess, and the quartz. So we do see that, as well as the other green minerals. So that is consistency. And if it's the igneous one that's getting some metamorphism, they're the green minerals that go with it. And I just wish that they'd get rid of all this English. Metavolcanics, metabasics, metabasites. Oh, really? Okay. Let's just give what it is the chemical name, can we? As a chemistry teacher? All right. I'm not a geologist, guys. Just a chemistry teacher. All right. Once we get to the chemistry, we get to the truth. All right. And so this is generally the classification. So you can see that there's the phyllites and maybe schists. That's the degree of metamorphism, and definitely the hornfels and quartzite. All right. And so what I did was, we're driving down from the upper, and we're going down to the dam now, and there's just all the road cuts are full of basalt, and it is a little greenish, and there are some green minerals in there. That's not a fresh cut. all these ones that I did, you'll notice that they're smooth and jagged. So they are smooth, and I just cracked them open to get a fresh cut to get those nicer pictures. So I've done that consistently for the sort of river survey, but then I didn't do it very often for the rest. All right, so I would have been nicer with a fresh cut. And then the dam itself, they are a greenish colour. They must be hornfels. This is very, very shiny in the sun, a little bit greenish. You can see some green minerals, even though the colouring is not that great under this lamp. And then finally I get to below the dam. This one's super green. It really is green in the sun. And so what I'm expecting now is every greenstone will show evidence of metamorphism, and it does. I don't think it's because there's foliation or it's hornfels. I'm saying no, neither this one here, the very, very last one is greenstone. All right, so just the hornfels again. You can see this is olivine or peridot or something, one of the green minerals. It's got a fine black matrix. I didn't do fresh cuts on any of these. I didn't smash them open with a hammer. But I think that was good enough and fairly consistent on the outside anyway. Where are we? This one's quite nice, especially the micas. It's all shiny, and the foliation. There'd be some quartz and biotite foliation. That's almost definitely Greenschist, I would say. It's gone a bit further. And these ones are similar, but not as far. That's a really nice green mineral. It's like a really nice green. It's a bit faded in there in the camera. You can start signs of foliation. Remember, this 1 to 10 is always 1 centimetre, by the way. And then the hornfels. And so this one's the only one I think I'm going to call a greenstone. As a non-geologist, I'll just stick my head out there and say, this is my guess, okay? Because there's some very nice different coloured green minerals. And the whole thing is green in the sunlight. It doesn't look that green under the lamp. And it's not foliated. They're cross striations of the quartz. And so that's the greenstone. So I thought that was quite successful. I think you can quite confidently pick up anything green on the North Pine River and be pretty confident it is some slight metamorphism of basalt or some sort of sedimentary rock. And it'll show some quite really nice signs of metamorphism, striations and foliations and stuff. Okay, so I think all goals achieved. All right, hope you enjoyed.